You know, for decades, we've been writing code as if it's a conversation just between human developers. But what if that's all about to change? Today, we're going to talk about the architect's new clothes. This idea that our tried and true coding practices might be totally out of style for this new era of intelligent AI agents. Let's dive in.
And really, it all boils down to this one single question. Because more and more, the main consumer of our source code isn't a person with a coffee cup, it's a large language model. And folks, that changes everything about how we need to think about building software. So here's our game plan. First up, we're going to meet this new reader and get into its very specific limitations. Then we'll get into the nitty-gritty of tokenomics and uncover some new architectural patterns built for AI. We'll even look at some wild, advanced techniques, tackle that big human versus machine debate, and finally, we'll try to picture what the architect's job looks like in this brand new world.
Okay, so who is this new reader? Well, it's the AI agent. And you have to understand, its biggest problem isn't the same as ours. It's not about working memory or getting distracted. It's all about something called the context window. And this finite little box of information an LLM can pay attention to at one time, that's the single biggest bottleneck we now have to design for.
Think about it like this. For us humans, breaking code into tons of tiny, clean files is a lifesaver. It helps us manage complexity. But for an AI, oh no. Every single one of those files it has to open is a super expensive operation that just eats up that precious context window. If information is scattered all over the place, the AI is likely to just lose the plot.
So, if the old way of writing code is starting to look a little threadbare, what's this new fabric we're supposed to be using? Well, the answer is all wrapped up in the economics of tokens and a whole new way of measuring what good code actually looks like.
And that new metric is called semantic density. Now listen, this is the important part. It's not just about writing less code, it's about packing the absolute most meaning into every single token the model has to look at. We're trying to maximize the signal and just crush the noise.
Yeah, it really boils down to this super simple formula. Semantic density equals meaning divided by tokens. Every token, and I mean every single one, from a variable name to a curly brace, it has a cost. And our job as architects is to make sure each one is pulling its own weight and carrying as much useful information as it possibly can.
And this just lays it all out, plain and simple. On one side, you have these wasteful, zero-information tokens. You know what I'm talking about, all that boilerplate, that framework ceremony that has nothing to do with your actual business logic. And on the other side, you have these beautiful, high-information tokens, like long, descriptive function names or crystal-clear type definitions that tell the AI exactly what is going on.
So just how bad is this boilerplate problem? Well, get this. In a pretty typical enterprise app, the ratio of all that framework fluff to the actual important business logic can be as high as 8 to 1. Think about that. 8 parts of just noise for every 1 part of actual useful stuff. That is incredibly expensive for an AI agent to sift through.
And this quote right here, it just hits the nail on the head. This is what some are calling the file organization paradox. You know all those tiny little files that we love because they feel so clean? Well, for an LLM, opening each one is a costly tool call that stuffs its limited memory with a bunch of imports and boilerplate, hiding the 18 lines of code it actually needed.
All right, so we get the problem, right? The old ways of dressing up our code just don't fit this new reader. So now it's time to check out the new wardrobe. These are the architectural patterns tailored specifically for AI agents. This table lays out the whole shift in thinking perfectly. Instead of short, cryptic names that nobody can remember like proc_PMT, we use these rich, intent-filled names like process international wire transfer. And instead of spreading a single feature across a dozen tiny files, we pull it all together into what's called a vertical slice. We're moving from implicit to explicit, from high ceremony to just direct logic. Let's break down 3 of the most important patterns. First, there's vertical slice architecture. You put everything for one feature, the logic, the tests, even the docs, in one single place. This drastically cuts down on that expensive file hopping. Second, a file called CODEMAP.md. Think of it like a high-level map of your whole codebase, so the AI can figure out where to look without wasting time reading every file. And finally, explicit typing. This gives the model a perfect blueprint of your data, which takes out all the guesswork. Okay, so we've seen the everyday wear, but now let's look at some truly cutting-edge stuff. You can think of this as the high fashion, the haute couture of agent-friendly design.
This is where we're really pushing the boundaries of what's possible.
Okay, one of the coolest ideas out there is something called context folding. Imagine an AI agent is working on a really complex problem. Instead of cluttering up its main line of thought, it can branch off, create a totally separate temporary space to solve that one little subproblem, and then, and this is the genius part, it returned to the main thread with only a quick summary of what it did. This keeps that main context window lean and laser-focused.
And here's another advanced technique, using multiple agents that work together. With something called problem tree decomposition, you have one agent that's a generalist, and its only job is to break a huge task down into tiny, indivisible little pieces. Then you have specialist agents that go and solve each piece. By building the solution from the bottom up like this, it improves accuracy, and get this, by almost 24%. That's huge, especially when you can do it with smaller, cheaper models.
Okay, this all sounds amazing for the AI, but what about us? That's the critical question, right? In tailoring all our code for machines, are we accidentally making it impossible for humans to read? Are these new clothes even wearable for you and me?
And the answer is, well, mostly yes. The great news is that a lot of these principles, like having really clear, descriptive names and using explicit typing, they're a huge win for both humans and AI. Everybody benefits from clarity. The main place we run into trouble is file size. We tend to like small files. The AI pays a heavy token tax for them. But the compromise seems to be that vertical slice architecture. Yeah, the files are bigger, but having all the related code in one place can actually make things easier for us humans too.
So, where does this leave the software architect? Does this whole new paradigm mean the role is becoming obsolete? No, not at all. It's actually the complete opposite. As we're about to see, this elevates the whole discipline and makes it more critical than it has ever been.
All right, let's bring it all home with 5 critical takeaways for every architect out there. Number 1, always prioritize semantic density. 2, adopt vertical slice architecture to keep all your context together. 3, start using problem tree decomposition for those really gnarly, complex tasks. 4, look into active context management techniques like folding. And finally, number 5, standardize how you give instructions to your agents with things like a CODEMAP.md file. Because at the end of the day, as writing the actual code gets cheaper and cheaper, it's the architectural judgment to design these readable, resilient systems that becomes the real bottleneck for innovation. So, I'm going to leave you with one final thought to chew on. Take a hard look at the systems you work on every day and ask yourself this question. Are they tailored for the past, or are they truly ready for an automated future? Is your code base dressed for yesterday's developers or for tomorrow's agents?